Hello everyone and welcome to part 2 of this TyFlow and Redshift tutorial. Today I'm going to show you how we can make this appearance effect of our object or symbol simply using Stoke and of course Redshift. First off we go here in the scene, nothing changed yet since part 1. And we go into our TyFlow setup and then we just disable this and then we start another birth event and we only emit particles at the start, so disable this checkbox for an end frame. And yeah, maybe we can set this up to 10,000 and then we go here, put the position object operator and choose our shape. Okay, and let's see. Yeah, the aim is that the shape should be covered entirely by particles, so the default mode of faces as the location is correct. So we have nothing else to do except one thing, and for that I will go here in this layer and I will create a dummy object to test something. Okay, just place it in here, very close to the surface. Yeah, somewhere here. Okay, that's good enough. And then we go back into TyFlow and we will use an object test. Okay, for the object test I will also create another event with particles in display mode with another color, of course, so we can detect the conditions. Yeah, of course the object test needs this dummy as its object, and here we can see the test distance, which is still the default value of 10, and I will reduce it to maybe 0.5. Okay, that's good enough. So value of 0.5 is this little spot here. Yeah, maybe it's better if we increase the particle count up to 1 million. Oh, my bad. I should go back to frame 0 to save simulation time, because it's useless to simulate the entire simulation if I just want to test something. Okay, yeah, maybe would also be a good idea if I just disable the render objects so I can see beyond. Now the important part. The particles in the birth event will get a particle group operator, and the group is 1, and here the particle group will be 2. Very important, let this checkbox be checked to change the particle group, so the particles will turn into group 2 exclusively when they fulfill the condition of this test. Also, I would like to add another test, and this is called the property test. And this will be applied to neighboring particles, but best would be if I would just disable this, and as long as I haven't found the right settings. The test will also be applied on this event, but continuously, yeah, that's correct. And also the particle count that is tested will be much lower, maybe something like 5, and the radius of course will be very low, something like 0.1. so the particle in here has, with a greater than condition, more than 5 neighbors, or maybe 3 neighbors I would say, in this small particular radius. And if they are, and that's very important, from group 2 in here, they will join them. The first particles from group 2 will be caused by this operator, and then all the other particles which are very close to that will join them. Okay, and let's see how fast this pattern will grow. Okay, it works. Well, here on this body, which is the biggest, or which has the biggest surfaces, it will take from frame 0 to frame 271 just to let these particles grow over the body. Yeah, that's good. I think the speed is good enough, or yeah, well, I can also increase this a little bit. So I was imagining something around 5 or 6 or maybe 7 seconds. So maybe this should be 100 frames faster. Yeah, but it's okay. We will do some changes anyways. And this is right here because I don't like this pattern to grow so flat and so clean. So we need some turbulence, and the turbulence can be set by a global pattern, and this is done by a noise. And we will change the parameters in the following way. We will add a strength of 2 or 0.2, I mean, and a quite small scale, like let's say 22. And let's see how this pattern will look like now. Yeah, it's a little bit more noisy, but still I would like the scale to change to have more noise at the edge. So maybe we will reduce that again down to a value of, let's say 14. And also the strength could be a little bit more, something like 0.3. Okay, let's take a look again. Okay, the big danger in this case is that the noise will affect the growing, but we can solve this problem if we add a frequency to the noise that is applied on the spreading. Yeah, a low frequency like 0.2 will be good enough, I would say. Also, because I wanted this to grow faster, I will increase the radius to about 0.14, and also I will increase the number of neighbors for the condition up to 5. Okay, let's see again. Okay, that's good, I would say. As you see, sometimes it stucks a little bit, but then it comes back. I mean, the growing of the edge. Yeah, just like here. This is because we have applied this frequency on it. But it's okay. I mean, as long as the whole surface will be covered, it's okay. And also I like the speed. Now we are a little bit faster. Now it's about frame 248. It's all covered. Okay, well, maybe I will speed it up a little bit. So I will go for 4 neighbors. That will be the condition for our test. Let's see again. Okay, perfect. It's faster. Oh, but if I take a look at this, I would like a little bit smaller scale. Okay, let's go down to 9 and then it should be finished. Okay, well, that's good. But I would like this effect to be caused by the particles we have here that we created in our last part of the tutorial. So how do we do that? We go here, and we will also create in our last flow the particle group operator and give them the group of 3. And of course we will disable this test and put another test that tests the particle neighbors. But now it will test particles which are from group 3. Also, I would say I will take this value, this distance value. I will go here in the radius, or maybe a little bit smaller, like a radius of 0.4, I would say. And also before I enable this, I would like to change something. I will reduce the custom vector. So I will reduce it by multiplying it with a factor of 0.33. Okay, also I would change the distance parameter a little bit, so particles which are rather close to the surface of the symbol will be affected by this script in the new event. So maybe I will reduce it down to a value of 6. Okay, and now I will enable this event. These are the entire changes that I just did. You see here this multiplier and the lower distance value in the test, on the surface test operator. Okay, and let's take a look. Disconnect this. Alright. Okay, well that didn't work as I thought. I have to increase this radius maybe to a value of 1. Okay, all the particles are in the events where they should be. Oh, okay, I guess I made a mistake. In the TyFlow object, under the physics section, you need to uncheck the simulation group filtering, because now these events which have physics behavior are particles from a group. So we will just uncheck this and watch again. Alright, that's good. No intersections anymore. And the ground collision is working again. Alright. Okay, everything's good. And let's get back into TyFlow. But first we can delete this. We no longer need this. And here in TyFlow, we can start exporting the particles from group 2 because we are only interested in them. Okay, let's go here, export particles, and choose PRT. Oh, before I forget, I would like to have more information about them for later. So let's go to custom properties, timing continuously, of course. And we will create a new custom float, and this will be the event age in frames, I would say. Okay, and now we will export this with the custom float. Maybe it's better to copy this operator by using Shift or press Shift on your keyboard and drag this into the other event, just to make sure that the particles are initialized with the additional custom channel. But anyways, we will only export particles from group 2. Alright, and let's export. Okay, now that the export is over, we can disable our TyFlow. And we will create another layer, which we simply call Stoke. And in this layer we will create a Krakatoa PRT-Loader. And we will add our particles, of course, that we just cached. And of course we will add all the particles that we just cached in it. Okay, and let's see. Move the particle PRT-Loader, of course, to world origin. Alright, and let's go into this PRT-Loader by creating a magma modifier. Okay, and this will only be affected by the custom float that we created. Okay, next thing would be we go here onto the Stoke tab and we will create a Stoke Field-Magma object. And okay, this is big enough, or maybe we give it a little offset so the entire object will be in it. That's good. And of course we will also increase the spacing, because this will directly result in the resolution of our texture later, or maybe 0.01. We will reduce this viewport representation, and let's get in here in this magma editor for the field. Okay, input particles, of course, because now we need to use this PRT-Loader. So pick particle object, choose PRT-Loader. Okay, and now we use the particle query, And to get the index, to get information of the particle color of course, we will need the closest particle operator, or the nearest particle operator. And for that we take the position, the world space position, and use this index. Okay, this should also have the condition if the closest particle has a certain distance. And we can achieve this easily by a subtract operator. Subtract the position of the nearest particle with the position in world space. And then we go to the vector section and use the magnitude. Magnitude is the length of this distance vector of these two positions. And if this magnitude is bigger than, I would say, a value of 0.05, it will cut off. So 0.05 is the 20th part of 1, so we will multiply this by 20. Use a clamp function. Then we will reverse this value by simply subtracting it from 1. So this will cause, if the particle has no distance to the position in world space, then it will have a value of 1, because 1 minus 0 equals 1. But I would like to give it a little offset, maybe an offset of 0.5. Okay, so particle will cause the maximum value of the color channel by multiplying it with the reversed distance value, and this will result into a color output. So we created a field with voxel values, I would say. Okay, and now it's time to apply this on our surface. We first need to apply a modifier to get UV coordinates. And this is simply the Unwrap UVW modifier. Go into the UV editor. Simply press Ctrl A to select each face. And then go here, press the peel mode, and press the flatten by material ID. So each face or each polygon will have a proper place here on this UV map. So next thing will be we switch our render from Redshift to scanline. So the renderer scanline does support the field texture from Stoke, and that's what we need right now. Okay, go to the material editor, then we'll create a scanline standard material and go to the maps section and then simply choose a field text map. Pick the Field-Magma and choose the channel, which will be color, and simply drag it into diffuse color part of the standard material. Let's take a look how this field is applied on the surface. You can simply create an omnilight just to see something inside of scanline. Oh, you also need to apply this on the shape. Okay, press render and look what we have. Go back to the PRT-Loader and then use for viewport the 100%. Press render again. Okay, this looks good. Alright, and now we get over to bake this texture, or we render this texture. For this we need to select our shape, our UV coordinates are in the channel 1. Yeah, that's correct. And now we select on our shape the diffuse map. Just take a path where you want to save it. I will also increase this resolution. Yeah, right now I guess we are good to go here. We go to our render settings, choose the active time segment. This will be applied here if we start to render. The mapping coordinates will of course be channel 1. Okay, then I guess it's time to render these textures of our field into image sequences so we can apply this in Redshift later. Okay, but before we start, we also have to set up the target map slot, which is in this case diffuse color. Okay, let's start. Okay, we are done. Switch the render engine back to Redshift. Then go back into your material editor and then create a Redshift material blender. And for that, you need to plug your current icon material in it. And for the layer 1 blend color, simply create a bitmap, which will of course be the baked texture. Okay, here it is. And now plug it into the layer 1 blend color. And as the base material, we simply create a new Redshift standard material, of course. And this one will have no reflection, no base color, but only a transmission. And this will have its weight at 1 and no reflection roughness. Okay, now it should be completely transparent, I would say. Of course, the IOR should also be simply 1. Okay, and now it's an invisible material and this will be the base. Okay, now we apply this material blender on our shape. And let's have a first look. Somewhere here where it will build up. As we still can see with the PRTs, but I will disable this whole Stoke layer. Okay, let's take a look. Of course with the render objects enabled. Okay, that's quite good, but I almost forgot that I have this OmniLight that I created for the preview render in Scanline. So I will just delete this now because I no longer need that. Let's have another look. Okay, that's pretty good, I would say. But here, when there's this face that intersects with the floor, we can see these artifacts and we don't want that. So a very simple method to get rid of this would be if we just take the floor and move it down a little tiny bit. Just about with a Z value of -0.001, I would say. So there's no intersection and we should get rid of this. Let's look again. Alright, perfect. But now we get over to this glowing edge effect. And how do we do that? We go back into this material editor. We will copy this bitmap sequence. Give it a tiny offset, like 1 frame. Use the ping pong mode, so the first frame at frame 0 and the rendering will also be black. And then we will use a Redshift map under the math vector section. And this will be, of course, the Redshift vector subtract. And this will be multiplied with the Redshift vector mul map with a color in Redshift maps, in the user data section, the Redshift color user data. And for that I would pick maybe a blue color, something like this. This could be good. And apply this and plug it into the emission color port. And of course the emission color will have a weight of, let's say, 2. Okay, and once more we will take a look. Alright. Yeah, that's good, it's okay. And now let's take a look at this from the camera and also with our TyFlow enabled. But here, before I re-enable this, I will disable the simulation with the 1 million particles, so we save a lot of time. Okay, let's have a look. Okay, this looks really good. I would just change something this time also with the camera. I will just increase the aperture. Yes, so we have more depth of field, maybe with the value of 1.5. Go to another frame for our last test, and then it would be time to render this whole animation. Yeah, somewhere around here could be good. Maybe there are also some nice edges to see, but it always depends on your taste. You can also choose an offset of 2 frames if you want this edge to be a bit bigger, but I like this. Another thing, by the way, is that I really enjoy that Redshift renders so fast on the GPU. Yeah, I think this is good. Also with the particle settings here, I like that. We can go to render this and maybe one last test with an aperture of 1. Oh yeah, I think this is fantastic, especially if you see these glowing edges in combination with this increased depth of field. Yeah, I will go for that. I will render this, and that's it. That was the entire tutorial. Please like and subscribe, and feel free to ask me any questions if there's some misunderstandings. And yeah, I'll be back with new tutorials, and yeah, thank you for watching if you have made it so far, and bye bye.